In order to get our robot to navigate a known maze, we need to change the way the forward whiskers function works just slightly. As it stands, the forward whiskers function will tell our robot to go forward until it comes to a wall, and it's only at this point that we're able to give it new instructions such as turn left or turn right. What we need is the ability to make our robot go forward the distance of a single cell. And then at this point we could tell it to turn right and go forward the distance of a single cell again. Using this cell by cell technique, we could eventually get our robot to navigate to a desired end goal. Unfortunately, our robot does not have any sensor that will allow it to measure how far it's traveled. Thankfully, its motors are powered using a voltage regulator which feeds them a constant 5 volts. Because the motors are given 5 volts irregardless of the energy remaining in the battery, the time that the robot travels is proportional to the distance that it travels. So all you have to do is measure how far the robot travels over a given amount of time, and then you can calculate this distance. Or you could use trial and error. It's up to you. Now this is all we need to do in order to get our robot to navigate a maze. But we've already put a lot of time and effort into getting our robot to stop before it hits a wall, which turns out to be a little bit useful in navigating a maze. For example, if our robot were to start out but it veered a little bit to the right and then it travels the distance that it thinks it should to the next cell, it's going to end up a little bit too close to this wall. It might even bump into it. What we would like to do is make the robot stop just a little bit short so that it ends up right in the center of the cell. We actually already have this functionality. All we need to do is combine it with this logic to get a pretty smart robot. Sadly, we cannot use a delay statement to control how long the forward whiskers function runs because delay statements are blocking. What I mean by that is when the delay statement is used, nothing else in our program executes for the amount of time that you specify. That's a problem for our forward whiskers function because it needs to loop through the while loop every few milliseconds to measure the sensors and then use the information fed by those sensors into the motors to make the robot go straight down a corridor instead of veering into a wall. To get around this, we're going to create a new variable called starting time, and it's going to be an unsigned long, which is just a really big integer. We're going to set this variable equal to millis. Millis is just a function that returns the amount of milliseconds that have passed since the Arduino was turned on. The next thing we could do is just delete this part of the condition within the while loop and replace it with what I'm about to write. But that would remove the robot's ability to stop a little bit early in the event it gets too close to a wall. So instead, we're going to add the condition using an AND statement, and we're going to say millis minus starting time is less than 1905. Millis minus starting time is the elapsed time, the amount of time that has passed since the forward whiskers function was called. This needs to be less than 1905 in order for the while function to continue running. And the 1905 is basically the number of milliseconds needed for the robot to travel from the center of one cell to the center of the next cell. This is a number that I use for my robot. It's not perfect. You can definitely improve it using either a little bit of trial and error, some measurement. And you may have to make a much different number based on the type of maze you're running in, or your motors, or how your power regulator is working, or your voltage regulator is working. So play with this a little bit to get it just right. Once you've made those two changes, it's time to go to our loop and setup. We're going to delete the navigate labyrinth line from our loop, and we're going to add some commands to the end of our setup function. Commands very similar to the commands we used to navigate a known labyrinth. Once you have programmed a series of commands for your robot that you think will get it through the maze, go ahead and upload them and see how they work. Once your robot gets to the end of the maze, go ahead and change it up a little bit and try different configurations. See if there's a particular situation that your robot has trouble navigating.